Hi everyone! In this video, we will solve equations with fraction coefficients. Fractions can sometimes get messy. We could find the common denominator and add all of these fractions together and work through it that way, or we can get rid of them, and I like that method best. To do that, we look for the lowest common denominator. We have two denominators, 3 and 5, so the lowest common denominator between those is 15. We take the lowest common denominator and multiply it to both sides of the equation, and because we multiply it to both sides, it keeps the equal sign balanced. This means that it's a valid operation that we can do. On the left side, I need to multiply the 15 to every single term. So we end up with 15 times negative 1/5 n plus 15 times 2/3 n minus 15 times 1/3 n equals 15 times negative 1/5. Now, we could multiply first or simplify, and I prefer simplifying because we end up with smaller numbers. 15 divided by 5 is 3. 15 divided by 3 is 5. 15 divided by 3 is 5. And 15 divided by 5 is 3. Now we no longer have anything in the denominators, which makes this much simpler. So we just multiply all of the numerators together, and we're left with 3 times negative 1 is negative 3, don't forget the n, plus 5 times 2 is 10, don't forget the n, and 5 times 1 is 5 with an n, and on the right side we have 3 times negative 1, which is negative 3. This equation looks much nicer to go ahead and solve. On the left side, they're all like terms, so we can just add and subtract those together. Negative 3 plus 10 is 7n, minus 5n equals negative 3. 7 minus 5 is 2, so we have 2n equals negative 3. Then, to isolate the variable, we'll divide by 2, and we are left with n equals negative 3 halves. And that's our answer. It's recommended to check by substituting your answer back into the original equation. You can always know if you got the correct answer. I don't have room to demonstrate that here. However, you can try it on your own. You don't have to move on until you know for a fact that you have the correct answer. And we're all done.